children, how are you? I hope you all are happy and healthy. So children, in the previous class, you have learnt about the curved surface area, total surface area and volume of various solid objects. And you had also made a chart for the formulas of the same. Do you still remember those formulas? If yes, then answer a few of my questions. So, let's try to complete this chart once again. So tell me, curved surface area of a cube and total surface and volume. Right. Now cuboid, its curved surface area, total surface area and volume. Very good. Now tell me about a cylinder. Its curved surface area. Right. We just need to multiply the circumference of the base with its height. 2 pi r into h. And now total surface area of the cylinder and volume. Now it's cone's turn. Curved surface area of a cone, total surface area and volume. Sphere, curved surface area, total surface area. Yes, that will also be the same. And volume. Right. Hemisphere, its curved surface area, total surface area and volume. Now tell me which unit of these cannot be used to show the volume of a solid shape. Meters cube, decimeter square, kilometer cube. We know decimeter square cannot be used to show volume. You know very well. Why is it so? Volume of a solid object with straight vertical walls is equal to the area of the base multiplied by its height. True or false? Yes, true. What will be the degree of any formula for volume? 3, 2 or none of these? The degree of any formula to find area of any shape is always 2. True or false? True. Okay, 555 divided by 100 is equal to 5.55. True or false? That's true. It is being divided by 100. So, we can leave 2 digits from right and put the decimal here. So, it will give us 5.55. So, if you remember all these formulas and you have also answered all my questions correctly, then you are going to enjoy this chapter a lot. So now, let me show you a few pictures and you will have to identify which shape is this. So look here. Which shape is this? Okay, and this one? Yes, and this one. What will you call this? Is it a cylinder? Look carefully. Okay, now look at this one, a capsule. Is it cylindrical? Okay, now look at this toy. Okay, now a toy for kids to play with. What is the shape of this toy? And this ice cream cone? Okay, just leave them. You answer another of my questions. The question is, when you sit down to eat food, then do you eat whole of the chapati in one go? Or when you need to climb the stairs, do you climb all the stairs together in just one big step? And when you have your exam, do you prepare for whole of the syllabus in just one day? No, it's not possible to do any of these. Whenever we need to eat food, we always make small bites of the chapatis. And when we climb the stairs, we always climb one stair at a time. And when we prepare for the exam, we always study regularly for whole of the year. Whenever there is a job to do, it's always good to divide the whole job into smaller parts. Then it becomes very easy to do it. So, now look at this picture again and think about it. Which shape is it? Suppose I divide this whole picture into 3 parts. The cylinder in the middle and then 2 hemispheres at both the sides. Can we do that? Let's try to do it with hands on. Look, here is a ball, a smiley ball. I have tried to cut it from the middle to make two hemispheres. Like this. Now, if I place these two hemispheres at the two sides of a cylinder. See, here is a cylinder. Now, I am placing this one here and this one here. Now, does it look like that tanker or the capsule? It has cylinder at the middle and two hemispheres at both the sides. So now, let us also try to make that toy. See, hemisphere at the bottom and a cone at the top. Now it looks like that toy. Now this ball was solid, so we got two solid hemispheres by cutting it from the middle. Now suppose if I have a sphere that is hollow from inside. See, like this. It was a sphere and I have cut it into two parts. So I have got two hemispheres that are hollow from inside. Suppose we need to calculate the curved surface area of this hemisphere. So what do we need to do? We can calculate the curved surface area of its interior or the exterior. It will be same. Yes, if the thickness of this sphere is supposed to be negligible, then the surface area of its interior, also its exterior, will be absolutely equal. But the thickness should be negligible. Now look at this also. Here we have got two circles, one bigger one and a smaller one. Now suppose we need to calculate the area of this strip, this circular strip. Then how can we do that? Suppose we are given the radius of this circle, also the radius of this circle. So can we calculate the area of this circular strip? Yes, that's easy. For that, first we will calculate the area of bigger circle and then we will divide the area of this smaller circle from the area of the bigger circle. Thus, we will get the area of the circular strip. If you understand this all, then you are going to enjoy this lesson a lot. So, let's begin. This chapter is very interesting, but there are a lot of things that need to be taken care of. So, let us begin by discussing those things only. So, first thing is that you should always read the question completely, at least twice. You will think that it is a wastage of time, but no, it is actually going to save your time. Let me tell you how. For example, sometimes at the end of the question, it's written that you need to take the value of pi as 3.14. Because if nothing is said about pi, we usually take the value as pi equals to 22/7. But if at the end of the question it is mentioned that take the value of pi to be 3.14. If you will not read the question completely, then you may not be able to do that. In that case, no doubt you will be able to solve the question. You will be able to do the calculation. But then it will not be that easy. And it will also take a lot of your time. The second thing is that you should always take care of the unit. Suppose in the question, some measurements are given in meters while some other are given in centimeters. Then you should always make sure that you make all the measurements same. Like either you convert meters into centimeters or you convert the centimeters into meters, so that all the measurements are in the same unit. Only then move ahead with the calculation. Otherwise your answer will be wrong. Also, always take care of the unit that you write with the area and with the volume. We all know that for area, we use meter square, centimeter square or kilometer square. And for volume, we use meter cube, centimeter cube or kilometer cube. If you will write meter square or centimeter square for volume, then in no time your teacher will understand that actually you have not understood the concept of area or volume well. So, it's always important to take care of the unit used with area and volume. Now suppose in any question you need to add the curved surface area of a cone with the area of its base. So how will you do that? Will you calculate the value of pi r L first and then add it to this area? Is there anything common here? Yes, we can have pi r as common and in the bracket we will have L plus r. So it's always good to take anything as common if it is possible to do so. It will make your calculations very easy. Now look here. D is equal to 14 centimeters. Whenever you are given with the value of diameter, immediately, right at that time, convert it into radius. Because it is possible that later you forget to do that and your question will be wrong. There are two concepts, curved surface area and total surface area. It is very important to understand the difference between two. Why? That I will tell you in a forthcoming question. Now look here, 1 meter is equal to 100 centimeters. Then 1 meter square is equal to how many centimeter squares? Is it okay if I write 100 here? No, it's not okay. Why? Let me tell you. Suppose this is a square of 1 meter size. Its length is also 1 meter and breadth is also 1 meter. So the area will be 1 meter square. It's 1 meter square. Now suppose if I convert it into centimeters, then this same square will have the length as 100 centimeters and breadth also 100 centimeters. And now the area will be 100 multiplied by 100. That is 10,000 centimeters square. It means we need to multiply 100 also with 100. So we will have 10,000 centimeters square. Now it is correct. So let us look at another example. 1 kilometer is equal to 1000 meters. So 1 kilometer square will be equal to how many meters squares? We need to square this value also. So 1000 multiplied by 1000. That is 1 and 6 zeros. So 10 lakh meter square. Same is also true for cube. For that we will have to make the cube of the value. And last but not the least, whenever you get a question to solve with figures, always try to make the rough diagram of the figure given. And also make sure to mark all the measurements in that figure only. It will help you a lot. So now, let us begin the chapter. We will start with the first example. It says, Rashid got a plain top, laddu, as his birthday present, which surprisingly had no color on it. He wanted to color it with his crayon. The top is shaped like a cone surmounted by a hemisphere. See figure 13.6. The entire top is 5 cm in height and the diameter of the top is 3.5 cm. Find the area he has to color. Take pi equals to 22 upon 7. So, the first thing we need to do is to make the rough diagram. And here I have made this diagram. Now, the top of the toy is hemispherical and its diameter is given 3.5 centimeters. Now, the first thing to do will be, if diameter is 3.5 centimeters, then its radius will be 3.5 upon 2 centimeters. Now, this total height is given to be 5 centimeters. We need to find out the area of the toy, the complete toy. It is made with a hemisphere and a cone. We need to find out its total surface area. But for that, we will take the curved surface area of the hemisphere and also the curved surface area of this cone. Do you know why? Let me explain. Now this toy has been made like this, a hemisphere and a cone. Now to find out the total surface area of the toy, should we take the total surface area of this hemisphere? No, because total surface area of the hemisphere will be this outer surface area and the surface area of this circle. But when we make the toy, this portion has got in between these two parts. So it has not formed the area of the toy. We only need the curved surface area of this hemisphere. And same is true for cone also. We will take the lateral or the curved surface area of the cone because its circular base, it has come in between these two shapes. So it has not formed the area of the toy. So to calculate the total surface area of this toy, we will simply add the curved surface area of hemisphere and the curved surface area of the cone. So let's start with the calculation. So here, starting with the cone, the diameter of the cone is given 3.5 centimeters. So now we immediately need to convert it to radius. That will be 3.5 upon 2, that is 1.75 centimeters. Now the height, what will be the height of this cone? the total height of this toy is 5 centimeters. And here this radius. Now the diameter of the hemisphere is 3.5 centimeters, so its radius will also be 1.75 centimeters. If this radius, that is this length, is 1.75 centimeters, then what will be the height of this conical part? We can easily find out by subtracting this 1.75 from this total height, that is 5 centimeters. So for height, we can write 5 minus 1.75. It will give us 3.25 centimeters. So now we know the height of the conical part. But for curved surface area, we will require the L, that is the slant height, this one. And we know that L is equal to h square plus r square square root. Now height here is 3.25. We will need its square, and the radius is 1.75. Its square and square the root. 3.25 squared. It will give us 105,625, and here we will have the decimal. Similarly, for 1.75, it will give us 30625. I hope you know this shortcut of finding the squares. Okay, now the square root. Adding this, we will have 0, 5, 2, 6, 1, 3. Now we need to find out its square. I hope you know how to calculate the square root of these numbers. So its square root will be 3.7 centimeters approximately. Now moving to the hemisphere. Now for total surface area of the toy, first the curved surface area of cone, that is pi r l, and then the curved surface area of the hemisphere, that is 2 pi r square. Now is there anything common here? Yes, pi r. So we can write L plus 2r in the bracket. Now putting the values, pi r 22 upon 7 into r. R here is 1.75. Then L, which is 3.7. And 2r. 2r will mean the diameter, that is 3.5 centimeters. So here, if I remove this decimal and 7 to the 15 and 7 to the 35, have 4 here, 11. Now 11 upon 2 will give us 5.5, and inside the bracket we will have 7.2, adding 3.7 and 3.5. Now we need to multiply 7.2 with 5.5. So here 0693, that is the answer will be 3960, and decimal from 2 places here. So the answer is 39.6 centimeters square. That will be the total surface area of this top. So our second example is the decorative block shown in figure 13.7 is made of 2 solids, a cube and a hemisphere. The base of the block is a cube with edge 5 centimeters, and the hemisphere fixed on the top has a diameter of 4.2 centimeters. Find the total surface area of the block. Take pi equals to 22 upon 7. I hope you have understood what kind of shape is this. See here. Here we have a cube, a cubical box, and an hemisphere is placed above it. So to find out the total surface area, do we need to find the total surface area of the cube? In that case, this circular portion will also be counted. Let's see. See, our block looks something like this. A cubical block and a hemisphere above this. Now, if we will calculate the total surface area of this cube, then this circle, that is below this hemisphere, it will also get counted. So we will have to subtract the area of this small circle from the total surface area of this cube. And then we will have to add the curved surface area of this hemisphere into the total surface area of this cube. Let's see how to do it. So first of all, for area of the cube, we know the total surface area of cube is 6L square. So we will have to take that. But we need to subtract the area of this circle, that is below this hemisphere. That will be pi r square. So we will subtract pi r square from this area. And then we need to add the curved surface area of this hemisphere to this area. And that will be 2 pi r square. So looking at this formula, we will have 6L square minus pi r square plus 2 pi r square. So that means we will have 1 positive pi r square. So this has become the formula for total surface area of the toy. Is there anything common? No, there is nothing common. So we simply need to put the values here. Now this cube has the length 5 centimeters and the diameter of the hemisphere is 4.2 centimeters. So the radius will be 2.1 centimeter. Now putting these values, we will have 6 into L square, that is 5 into 5 plus pi will be 22 upon 7 into R. R is 2.1. So we can write 21 upon 10 into 21 upon 10. Now solving this, 5 5s are 25 and 6, this will give us 150 plus here. Now we need to multiply them. So 63 multiplied by 22. It will give us 1386 upon 100. So it will be 150 plus 13.86, that is 163.86 centimeters square. That's the area of the block. So the next example is a wooden toy rocket is in the shape of a cone mounted on a cylinder as shown in figure 13.8, like this. A cone mounted on a cylinder. So this total height is 26 centimeters and height of this conical part is 6 centimeters. So can we calculate the height of this cylindrical part? Yes, 26 minus 6 will be 20 centimeters. So this height is 20 centimeters. The base of the conical portion has a diameter of 5 centimeters while the base diameter of the cylindrical portion is 3 centimeters. If the conical portion is to be painted orange and the cylindrical portion yellow, find the area of the rocket painted with each of these colors. Take pi equals to 3.14. So we need to take the value of pi equals to 3.14. This we will write here. Now this conical part has to be colored orange and this cylindrical part has to be colored yellow. Now if we want to color this conical part, then we will color the curved surface area. So what about this part here? Here the base of the conical part will be like this. It's circular and there will be this circular base of this cylinder. It will be like this. So we also need to color this circular strip also because that portion has also to be colored. So the area, for the area of the circular strip, we will need the radius of both the circles. Now the diameter of this bigger circle is given 5 centimeters and the diameter of this smaller circle is given 3 centimeters. So we can easily calculate the area of the strip. So let's start with the orange part. For the curved surface area, the formula is pi RL. And for this strip, first we need to calculate the area of the outer circle, that is pi R1 square. Suppose the radius of the bigger circle is R1 and that of the smaller circle is R2. So we need to subtract this area pi R2 square from this one. So pi RL plus this. Here this R is also 1. So let us start by calculating the area of this conical part. For that we will need pi RL and the area of this base, this circular base. But it is joined with this cylinder. So what is the area that we need to calculate? See, the base of the cone looks like this. A circle, the bigger one, the conical base, and a smaller circle between this. This is the spherical, this corner of cylinder. Now the diameter of this bigger circle is 5 centimeters and that of smaller circle, let's mark it like this, 3 centimeters. we need to calculate the area of this strip. So for that, what can we do? We will first calculate the area of the bigger circle and subtract the area of smaller circle from that. Suppose the radius of bigger circle is 1, then we will write pi r1 square minus pi r2 square. R2 is the smaller radius. It will give us the area of this circular strip. Let's solve this one first. Here, the diameter of cone is 5 cm, so radius will be 2.5 cm. And diameter of cylinder is 3 cm, so radius will be 1.5 cm. So here we can take pi as common, and in the bracket we will have r1 square minus r2 square. Now putting these values, we will have r1. r1 is 2.5 here, so 2.5 square minus r2 is 1.5, so 1.5 square. It will give us 2.5 square is 6.25 and 1.5 square is 2.25. Subtracting this, we will have pi into 4. Now let's use this one here. Now for calculating the area of cone, we will require L. We know that L is h square plus r square square root. Height here is 6, so 6 square, and radius here is 2.5, so 2.5 square root. Now 6 are 36 plus 2.5 into 2.5, it will give us 6.25. Adding this, we will have 42.25 square root. Now we know that this is the square of 6.5. So L here will be 6.5 centimeters. Now for area of the cone, we will have the curved surface area pi RL, and the area of its circular base we have just calculated, it is 4 pi. So we can write 4 pi. Now pi can be brought as common, so we will have pi and in the bracket RL plus 4. The value of pi will be 3.14. R here is 2.5 and L is 6.5 plus 4. Now we need to multiply 6.5 by 2.5. It will give us 16.25 plus 4. So 3.14 multiplied by 20.25. So it will give us 635850 and decimal here. So the answer will be 63.585 centimeters square. That is the area of the orange part. Now let's calculate the area of the yellow part. For yellow part, we just need to calculate the curved surface area of the cylinder, that is 2 pi RH, and the area of its circular base, that is pi r square. Now, is there anything common? Yes, pi r can be brought as common, and in the bracket we will have 2h plus r. Now putting the values, pi r will be 3.14 multiplied by r, which is 1.5, and in the bracket 2 into h. H here is 20 plus r is again 1.5 centimeters. Now 3.14 multiplied by 1.5, it will give us 4710 and decimal here, and inside the bracket we will have 40 plus 1.5. So here we have 4.71 multiplied by 41.5. Now multiplying this, So we will have 195465 and decimal after 3 places here. So the answer will be 195.465 centimeters squares. So children, that's all for today. I hope you have understood this all well. In the next part, we will try to solve some questions of 13.1. You can also try them by yourselves. And now we will meet in the next part. Thank you. Have a nice day.